Hi, this is Mr. Max with Sankofa Mathematics. I gave a test to the grade 11s. It's on functions. So this is just sort of doing the corrections of this test. So the first one says a function is defined by f of x, which equals to 3x plus 4. Given that f of k is equal to k, so that means k equals to 3k plus 4. So everywhere where you have the k, or the x, you just replace it with that k. So then you solve this particular equation in order for you to find the value of k. Alright, so this is 3k, so you're going to have minus 2k is equal to 4. Okay, so in turn that will be k equals to 4 divided by 2, negative 2, so k will equal to negative 2. They say you must find the inverse, so the inverse of f of x, well, should not be a problem to find the inverse. So remember, you can replace that whole thing with y equals to 3x plus 4, and then what you can do is you can swap these letters around and make y the subject of the formula. So when you do that, you're gonna get that it's gonna be x minus 4 upon 3. So what you now have to say, because we're not looking for y, we're looking for the inverse, so the inverse of that will be x minus 4 upon 3. Right, so you have another question here. So again, these questions are taken from past papers. It says here you must find the value of 5.5, f of 5.5. So everywhere where you have the x, you just substitute that with the 5.5. All right, and just punch it in your calculator, and you should be able to get the answer. Okay, right. So if I bring up my calculator, so I've got 5.5 plus 2, well, so that gives me 7.5. Okay, so in this case I have got 7.5. I'm gonna multiply that. All right, bring my calculator back. So I'm gonna multiply that with 2 times 5.5 minus 1. Close the bracket. Well, what do I get? I get 10. Alright, so if I multiply that by 10, and clearly anything that you multiply by 10, the answer will just be 7.5. Right, again, here they're asking you to find the inverse. Find the inverse of g. You can find the inverse of g. Remember, this is the original function. So this is like what do you put into this function in order to get an output of something. In any case, if you reverse this function, you should get a certain formula. Okay, and once you reverse that formula, you get a certain output. Now, here's two ways that one can do this. Obviously, you can go ahead and say, let me work out the inverse of the function. That's one way of doing it, okay? And I want to explain to you why that concept is not really necessary, but I will do it anyway. So let's say we do that, so that becomes y equals to a third, then you have 2x minus 1, okay? So we're going to swap around the letters. X equals to 1/3, and then it's 2y minus 1. So the objective, remember, is to make y the subject of the formula. So I'll multiply here by 3, and you also multiply this side by 3 in order to cancel out those 3. So you can have that left equals to 3x. Okay, right. So that brings me to 3x plus 1 equals to 2y. All right, and then y will be 3x plus 1 all upon 2. Therefore, the inverse of this function will be 3x plus 1 divided by 2. And now you can actually find what that value would be, all right, if you substitute it in there. Okay, and you'll get it's 15 plus 1, so that gives you 16, half of 16. So therefore g of negative g, the inverse of g, when you have 5, you'll get an answer of 8. Well, again, as I said, it's not really necessary to do that, and I want to explain this concept. If you were to take the function as the function is a third, and then you have 2x minus 1, if we say let that equal to that inverse, you see the whole thing we are going to do here in order for us to solve the value of x is we are going to do exactly the same like we did on top. So first I'm going to multiply by 3 like I did before. So I'm going to multiply by 3. So that leaves me with 2x minus 1 equals to, well, this is 15 here. And then what I'm going to do next is I'm going to add 1. So it's exactly the same stuff that I was doing here. So I was multiplying by 3. Can you see that? And now the 1 is already added, so to speak. Okay. So you see, I'll add 1 and then I'll divide by 2. So it's the same thing that I will be doing here. Okay. So in order for me to find this, I'm going to say 2x equals to 15, add 1. Okay, that gives me 2x equals to 16. And now I'm going to divide by 2. Alright, and then you still get that same answer. So you can simply, if you are given a function and you're supposed to find the inverse of a number of a value, let that value or that function equals to that value. Okay, and then it will definitely give you the same solution. Alright, we have another one here. So you have function f of x is equal to 3 plus x upon 2. Find f of negative 3. So f of negative 3 means everywhere where you have that x, you substitute it. Alright, so of course you're going to have 0 divided by 2, and anything into 0 is equal to 0. Now you have to find the inverse of the function. Again, you can say y equals to 3 plus x equal to 2, and from here you can swap the letters around in order for us to have our value in terms of x. Then you get, go ahead, multiply by 2, and then you have 2x minus 3 is equal to y. Therefore you can now say the inverse of x is 2x take away 3, because that is 2 has been divided, so now it is going to be it has been divided, now it's going to be multiplied. So you are reversing it as it is. Okay, question 4. You have got a function f and a function g. Explain why f of x is undefined when you put negative 1 for x. Well, let's see. When we have negative 1 for x and we put that negative 1, we are going to get 4 divided by 0. And we all know that division by 0 is not possible. Okay? That is why you have that fact. Division by 0 is not possible. Alright, so here you're supposed to find f of 3, no problem. So f of 3 will be 4 over 3 plus 1, which is nothing but 4 over 4. So f of 3, you are going to get an answer of 1. Now you have to take g, the whole g, in order for you to do this composite one. So you take this whole g and you substitute that whole g. You're going to substitute it into f. Always work your way back. So you're going to substitute it here, the whole of that. Alright, so that means I'm going to have fg of x is going to be 4 over, now that whole thing plus 1. So that whole thing being x squared minus 3. So if you go ahead and you clean this up, you're going to have x squared minus 3 plus 1, which is going to be 4 over x squared minus 2. And that is what we are looking at is our final answer. That's why we say you must simplify it, okay, so that you can take away this minus 3, add 1 to it. Okay, so they want us now to find the inverse of f. Again, we know that function f is, if we have to bring it quickly down, function f is equal to 4 over x plus 1. Okay, so 4 over x plus 1. So again, go ahead and write this as y equals to 4 over x plus 1. And then we're going to go ahead and swap those letters. So we got x equals to 4 over y plus 1. All right, I'm going to put that in bracket. Okay, so the idea is you are doing sort of cross multiplication. So that's going to be x and then y plus 1 here equals to 4. All right, and that is going to be xy plus x equals to 4. So what I'm doing is I am actually multiplying out so that I can have, remember I want to make a wider formula so that I can have 4 minus x here, and then I can take away that x by simply dividing 4 minus x over x. Well, this can actually be written as 4 over x minus x over x, which means that the inverse can now be written as 4 over x minus 1, because that 1 is the same as x over x. Okay, right, so this is the answer for this particular question. Okay, so you are supposed to show that f of x, which is our f of x is 4 over x plus 1, if I can recall well, and our g of x is x squared minus 3. Okay, x squared minus 3. So I'm going to have x squared minus 3. Well, I'm going to go ahead and put them in bracket because I'm sort of going to do a cross multiplication here. Okay, so that means I'm going to have 4 equals to x plus 1 times x squared minus 3. So we are going to multiply out here that with that. So that's going to give us x cubed. We multiply that with that. That's going to give us minus 3x. And then we multiply here. You're going to get a plus x squared. And positive for negative gives you negative 3. Right. So we can actually now go ahead and clean this up. So I'm going to have x cubed plus x squared minus 3x minus 3 minus 4. Okay, so that minus 4 is not positive. So the moment I bring it over, it becomes a minus 4. Okay, so there's the last part, which leaves me with x squared, or x cubed rather, plus x squared minus 3x minus 7. And this is what we are required to prove. Okay, so most of that work is whatever you do when you were doing cross multiplication. Question 5. You are given that f of x is equal to x plus a upon x minus 4. X cannot equal to 4 because it will make this impossible to do, because it will give you a 0 in the denominator. So we can have x as a 4. F of 10 is equal to 2. Find the value of a. So they are saying f of 10. So everywhere we have an x here and an x here, we're going to let it be substituted with that. And we're going to let the whole function equals to 2. So that means we're going to say 10 plus a over 10 minus 4 should equal to 2. Okay. All right. So that gives us 10 plus a is equal to 6, which equals to 2. So from here, simply a matter of just multiplying in order for us to get rid of that. So I'll have 10 plus a is equal to 12, and then a will be 12, take away 10, so the value of a then, a is equal to 2. Right, so they are saying find the inverse of f, negative 4. So again, as I said, you now know what the value of a is. So simple way is to say x plus 2, that is our value of a, x minus 4, let it simply be equal to negative 4. Okay, so it's very similar to the other one. You don't have to find the inverse of that value. All right, so again, perhaps you can put this in brackets and you can have that over 1, sort of a cross multiplication if you wish to look at it that way. So it will be x plus 2 equals to negative 4 times x minus 4. That is if you were to cross multiply. Okay, so this here will give us, so x plus 2, so this will give us minus 4x plus 16. Careful, don't get confused here that a negative times a negative gives you a positive answer. That is a very big thing. A lot of students are tending to make that mistake. Okay, so simple collect like terms. So I have 2 minus 16 equals to negative 4 x minus x. Okay, so that's going to change. All right, so that is minus 14 equals to minus 5x. At the end of the day, you're going to have x equals to negative 14 divided by negative 5. Therefore, x equals to 2.8. Okay, it has to be 2.8. You can grab your calculator just to make sure that you get to the same answer. Okay, so that will be negative 14 over negative 5. Okay, so the answer is 2.8. Negative divided by negative gives you a positive answer. Right, so if g of x is equal to, so we'll bring in another function here, is equal to x plus 2. So we are going to take this whole g and we are going to substitute it into our function f. Remember, our f of x now is x plus 2 over x minus 4. All right, so everywhere we have an x in this function, we are going to substitute here and here with the value of x plus 2. Right, so that means we're going to have fg of x is going to be, in bracket you have x plus 2 over, there you have x plus 2. Remember that one is a minus, so that was plus 2 there, that was minus 4. So we can go ahead, remove the brackets, and then have x plus 2 minus 4. And when we clean this up, we are going to be left with, eventually, the final answer will be x plus 4 over, and this is x minus 2. So that is the answer for the composite fg of x. Alright, so this part here is just information. The idea of a function is used in almost every branch of mathematics. The two common notations that we use is we have this general way where you say f of x is equal to, or we can say function f is such that x is mapped onto x squared plus 4. So this is the mapping. This is the mapping notation. So it's another way that functions can be represented. So just make sure you familiarize yourself that when you get stuff like these, maybe you can rewrite it like that and then you can continue like normal. Okay, so here we have got a function f of x is equal to x to the power x. Find the value of f of negative 3. So again, just simply say, okay, f of negative 3 means everywhere of an x that's negative 3 will be raised to negative 3. Okay, now they say give your answer as a fraction. So you have got here a negative index, and what it says, you must take the denominator, or you must take the base. Okay, you take the base, which is this negative 3, and you swap it, and now our power becomes positive. Alright, so you can just go ahead. Remember, this in a nutshell means negative 1 over 3 times negative 1 over 3 times negative 1 over 3. At the end of the day, you're going to have negative 1 upon 27 as a final answer. Right, they say when find 7.5, find the value when f of 7.5. So everywhere You're going to say 7.5. You're going to raise that to 7.5. You're going to get a horrible number, but we are going to write that number in standard form. So let's just do that. So we say, let's clear that. We say 7.5 raised to the power of 7.5. Well, the answer is 3,655,000. So it's 3,655,000. So let's make sure. What is the rest of the stuff? 606.791. But we're looking for the answer in standard form. So I'll say 3.66 times 10 raised to the power of 6. All right. So that comma is moving 1, 2, 3, 4, 5, 6. All right. And I'm just going to round to 3 significant figures in order for me to get that part. Okay, so I hope you still know how to write the number in standard form and stuff like that. It's just revision work. Right, they are saying you're supposed to explain why this is not a real number. Let's first see what it means, right? So I'm going to go ahead, I'm going to write this as a fraction. So it's actually negative 1/2. So negative 1/2 raised to the power of negative 1/2. Okay, remember what I said about negative fractions. I said this here, oops, that is a horrible color. So we said this here means you must take this base and you must swap it around. So in order for me then, I'm going to say it becomes negative 2 raised to the power of 1/2. Okay. Let's just go over that again. So it means the base is now negative 2 raised to the power, but now my half is positive. Right, anything raised to the power of 1/2 is the same as taking the square root. Okay, and the square root of a negative number does not exist. Okay, so you will see if you punch that in your calculator, it start giving you some weird answers, or you just get the idea when it says that, well, you get an error. So maybe I can show you that, what I mean. But you should know that the square root of some negative value is not going to see a whole text message that the calculator is giving you. So doesn't exist. So we can say the square root of a negative number it's not real. Does not exist in the set of all. Does not exist in the set of all real numbers. Okay. Right, then they say find the integer. An integer is a positive whole number or negative whole number or 0 for f of x. Remember our f of x is equal to x raised to the power x. So they say it should equal to that. So basically x raised to the power of x should equal to 3,125. Now, if you want to express 3,125 in prime factor form, 3,125 equal to shift prime factor form, you raise 5 raised to the power of 5. So x to the x is equal to 5 raised to the power of 5. Same denominator, same basis, same. Okay, the index here should be 5. Just to correct that one here. So when the bases are the same and the indices are equal, therefore the number we're looking for is 5. Well, it was a quick revision test, and I hope that you can go through it and pause and rewind if there is something that you did not get. Okay, so this is the work on functions. There's going to be a second test that I'm going to upload that I will give to the grade 11s that you can check out tomorrow.